The last data structure we're going to talk about in this chapter is the tuple. That's spelled T-U-P-L-E. Let's open up the interactive shell so we can look at how tuples work. First thing you should know is that a tuple is very, very similar to a list. We use a different delimiter, parentheses rather than brackets, to signify a tuple, and all the operations of tuples are similar to those of lists except for one detail, and that's the fact that a tuple is an immutable object, which means that every time you change a tuple, you're actually creating another copy, unlike a list where you can change it, as they say, in place. But with a tuple, if I make a change to the tuple, then that just creates another copy. So tuples are a little less efficient than lists because of that immutability. But other than that, they're exactly the same as you'll see through this example. So the first thing we'll do is create an empty tuple, and we do that by writing a open and close parenthesis alone. That represents an empty tuple. If we want to store some data in a tuple, we put the data inside the parentheses, delimited by commas, just like we do for a list. To access a tuple element, we use indexing just like we do for lists. We can return the length of a tuple with the len function. We can get a slice using slice notation. We can concatenate two tuples together to form a new tuple using the concatenation operator, which actually is just the plus sign. And then finally, let's create a string tuple. We can use the multiplication operator to replicate a tuple. So as you can see, all the operations that we performed on lists earlier in this chapter, we can also perform on tuples. There is one thing we can do with the tuple that we can't do with the list, and that's using it as a key in a dictionary, and we'll look at that later in the course. But for now, we're going to end this lesson on tuples because we've covered all the basics of how tuples are formed, and we'll come back to the subject later in the course. But now we're ready to move on to the exercises for this chapter. For this first exercise, we're going to demonstrate how to take a set of data and structure it as a list. So what you're looking at in front of you is a set of student names and a test score. So you have Raymond 92, Cynthia 83, Terrell 64, and so on. If this was an advanced exercise, we'd be looking at how to access this data from the file that it's stored in. But we haven't gotten that far yet, so we're just going to have to see how to enter this data manually into a list. So let's open up Python. Let's open the shell. And so what we want to do is we want to name this list something, so we'll call it grades. And what we're going to do is we're just going to take each name, store it as a string, and then store the test grade as a number or integer. Now what's important is you have to make sure that you do a couple of things. First, you have to make sure that each name is surrounded in quotes, either a single quote or a double quote. I'm using single quotes here. Then you also have to make sure that each grade is separated from a name by the comma. We'll have to continue this on the next line, and that's not a problem. Again, just making sure that we get our strings and our numbers correct, and that commas separate each one. And there's our list. So the way we can access this list is that we can assume that each pair is one record, if you want to call it that. So Raymond goes with 92, Cynthia goes with 83, Terrell goes with 64. So for example, if I want to see Raymond and his grade, I can type and then concatenate. But I get an error. The error says, cannot concatenate string and int objects. I did that on purpose, partly because I need to start showing you how errors look, because you're going to be running into them as you learn Python. And second, I wanted to bring up a point that you cannot concatenate strings and ints. In some of the lessons of this exercise, I've used concatenation, but it's always been with groups or with strings by themselves. But here you see a problem that we can't concatenate an int with a string. So grade sub 0 is a string, and grade sub 1 is an int. So what we'd have to do is, if we wanted to display these, we'd have to say grades sub 0 for the name, and then there's a function called str that then returns the integer as a string. And that's how we would pull that out. So if we wanted to see a different pair, we could say grade sub 2 plus string grade sub 3, and we'll see Cynthia and her test score. And notice those are bumped right next to each other. I'm not going to get into how to separate them now. There are several different ways we could put a space between them. For one thing, we could do this. I'll go ahead and show you one example. We could concatenate the space right there. And that's probably the easiest way to do it, like that. But we'll be working with strings more, and we'll be looking at examples of how to format things later in the course. Here I just wanted to demonstrate how to create a list data structure and put some structured data into that list. But having done that, we actually bring up a point that needs to be made, is that this data is actually better structured for a dictionary because we have the name and a grade. The name is a key and the grade is a value. So if we stored this data as a dictionary, then it would be much easier to retrieve a grade with the name than it was in the example I showed you here. So let's move on to the next exercise of this chapter, where we're going to do just that. We're going to take this set of data and store it in a dictionary. In the last exercise, we saw how to use a list to store multi-part data. In this exercise, we're going to look at that grade data again, and this time use a dictionary to store the data. Using a dictionary is a much more natural way of storing this particular type of data because a name and a grade are related as a key value pair. So in other words, if I want to retrieve a grade, I will ask for the student's name, and that will give me the grade. So using a dictionary is a more efficient and more natural way to work with this data. So let's see how to do that. So the first thing we're going to do is open up the interactive shell. And this time we're going to use a dictionary, so we'll start off with an open curly brace. And we have a name as a string, followed by a colon, and then a grade, followed by another name, a colon, and a grade, and so on until we get through all the names. So I'll just go ahead and type those in. I'm putting my space after the grade, but spacing doesn't really matter there. The most important thing is to have the colon to separate the key from the value and to have a comma between each key value pair. And this will be our last grade. So we close with a closing curly brace. So now if I just type the dictionary name, that will return the data. And notice that the data returned is not in the same order as the data entered. That's an important aspect of dictionaries. We don't store data in dictionaries because we're interested in the order that the data is being stored. Unlike, say, if we were trying to store an alphabetic list, then we would be interested in the order. But here we're only interested in a list of keys and a list of values. So the fact that Clayton appears first in the list when we retrieve it, even though it was entered fifth in the list, really doesn't make any difference. Because all we're interested in doing is being able to enter Clayton's name and retrieve his grade. So we can do that for a couple of more names just to verify that our system works. And there it is. Also remember that if we're interested in what the keys are, we can use the keys function to return a list of keys. And likewise, we can use the values function to return a list of values. Having a function that returns the values as a list would be useful if we were trying to compute the average, because it would be really easy to compute the average from this list of values, because we could simply sum the list and then divide by the number of grades to get the average. And that would be a lot easier than working through the dictionary itself. So that concludes this exercise, and what I wanted to demonstrate was, first of all, another example of how to use a dictionary, but also to point out that a lot of times the data will suggest to you the type of data structure that you should use. And this type of data is certainly more structured towards a dictionary than a list. We had to go through a few contortions to get the data out easily in a list, but with the dictionary it's just a matter of typing in a key as an index to retrieve a grade, and that was very simple. So with that, we're finished with this chapter on data types and data structures, and we're ready to move to the next chapter where we're going to talk about input and output in Python.